So this one is the part 2 for quadrilaterals, and in this video we will be studying about properties of quadrilateral. Okay, so in properties of quadrilateral, the first property that comes in our mind is that angle sum property, which comes in each shape that we study. So angle sum property, which you already know. Okay, so angle sum property, we already know about that. The sum of all the angles of a quadrilateral is 360 degree. Okay, sum of all the angles of a quadrilateral is 360 degree. Okay, so we can prove that as well. Let us take any quadrilateral, any type of quadrilateral. So this is a quadrilateral A, B, C, D. Let us divide it into two triangles. So I am drawing its one diagonal. So this is triangle 1, this is triangle 2. So in triangle 1, we know angle sum property of a triangle. Okay, this is one, this is one. Okay, so according to angle sum property of a triangle, okay, sum of angles of triangle 1 is equals to 180 degree. Triangle 2 का भी वैसे 180 degree. Okay, so here it is 180 degree, here is also 180 degree. So if you'll add it, we will find the angle sum of ABCD quadrilateral. So angle sum of ABCD quadrilateral is equals to 180 plus 180, which is equals to 360 degree. So this one you just have to remember. Okay, 360 degree. Okay, so this is one point that you need to remember about properties of quadrilateral. First one, angle sum property. Okay, so now we'll go to some theorems. Okay, maybe in your exam it will come that prove this theorem, or maybe question will come, you have to apply the theorem in that. Okay, so I'll show you, I'll prove here. Okay, your theorems. I think for this we will need another video, part 3, so that we will complete properties of parallelogram. We will see if I'll complete all the properties of parallelogram here only, so no need to make part 3 for it. Then in part 3 we will be studying about the midpoint theorem. Okay, so here we will be studying about properties of a parallelogram. Okay, properties of a parallelogram. Okay, so what are the properties? So here comes our first theorem. So according to your book, it is theorem 8.1. okay, this theorem 8.1. in this theorem it is written that a diagonal of a parallelogram divides it into two congruent triangles. Okay, a diagonal of a parallelogram divides it into two congruent triangles. Okay, so we will prove that. So first let's make a parallelogram. This is a parallelogram A, B, C, D. So it is written a diagonal of a parallelogram. So let's make a diagonal. जो बोला है वही बना देंगे diagonal. Okay. So it's written के diagonal DB. Okay, a diagonal of a parallelogram divides the whole parallelogram into two congruent triangles. That means it is saying you have to prove. What to prove? Prove that ABD triangle is congruent to BDC triangle. You have to prove that. Okay. So first, what do we have? Before solving this, we have to think of our given data. Okay. So what is our given data in a parallelogram? So the below figure is a parallelogram. So in parallelogram, we know that opposite sides are same. So I can say that this is equals to this. Okay, and this is equals to this. Opposite sides are same, and diagonal is a common side. Okay, so I can say that in triangle ABD and triangle BDC, we can say that AB equals to DC and AD equals to BC. Why? Now opposite sides of a parallelogram are same, equal. Okay, and another one is BD equals to common side. So hence we can say that, therefore we can say that triangle ABD is congruent to triangle BDC. Hence proved. Okay, hence proved. So if you, in your exam it is coming that prove that a diagonal of a parallelogram divides it into two congruent triangles, you just have to prove it. Okay, make a diagonal and prove that both the triangles are congruent. It's the easiest one. Okay, so also question may come where you need to use this theorem in that question. Okay, we will do that in the exercises. Okay, so this is the theorem 8.1. okay, so now we will go for theorem 8.2. Theorem 8.2. Okay, so according to theorem 8.2, in a parallelogram opposite sides are equal. Okay, in a parallelogram opposite sides are equal. Okay, opposite sides are equal. So this is the reverse of theorem 8.1, where you already proved that both the triangles are congruent. Okay, we already proved that that the triangles are congruent. Okay, you can say that, okay, we can say that AB equals to DC, and BC equals to AD, due to CPCT. Okay, hence we can prove that in a parallelogram opposite sides are equal. Okay, then this is theorem 8.2. then comes theorem 8.3. Theorem 8.3. See, these theorems are very important. Okay, maybe proof will come, or maybe you need to apply it in questions. Okay, so application in questions will do it after the completion of this part. I'll do another video for the exercises, and also I'll give you some homework for this. Okay, so theorem 8.3 says if each pair of opposite sides of a quadrilateral is equal if each pairs of opposite sides of a quadrilateral are equal, then it is a parallelogram. Okay, so if each pairs of opposite sides of a quadrilateral are equal, then it is a parallelogram. See, you need to understand the statement, what the statement states. So let's make a parallelogram. So this is a parallelogram A, B, C, D. It is given. What is given here? Given is that opposite sides of a quadrilateral are equal. Opposite sides of a quadrilateral equal. Matlab this equals to this and this equals to this. It is given. You have to prove that this is a parallelogram. Okay, so you have to prove that this is a parallelogram. So how we can prove that parallelogram? We know in a parallelogram opposite sides are parallel. Okay, opposite sides are parallel. So you need to prove that. What to prove? We need to prove that AB is parallel to CD and AD is parallel to BC. You just have to prove that. If you prove that, you can prove the statement. Okay, so let us draw one diagonal. Okay, so we already read about some angles and like properties of two parallel lines or two parallel line segments. Okay, there are some angles in parallel lines. You already read about that in parallel lines. So these are two parallel lines. If this is a transversal, we know about alternate angles, we know about corresponding angles, we know about internal angles, external angles, all of this. So these two are alternate angles, and we know that if alternate angles are same, then we can say that these two lines are parallel. Okay, so this is also alternate angle, this also alternate angle. Okay, and also we know if corresponding angles are supplementary, then we can say that both the lines are parallel. So here we can use alternate angle. So here in AB and DC, we can say that this angle and this angle, if we will prove that this angle is equals to this angle, we can say that these lines are parallel. Okay, so let's see how we can say that this equals to this, because we already proved here triangle ABD is congruent to triangle BDC. How? I am not writing it, it is already written that if each pairs of opposite sides of a quadrilateral are equal, it is already given that AB is equals to DC and AD is equals to BC. So using this one, you can prove that ABD is congruent to BDC due to SSS congruency. Okay, so here we prove that both the triangles are congruent. Hence we can say that angle ABD is equals to angle BDC. Okay, so similarly, if we will draw another diagonal here. Okay, so we can say that angle DAC is equals to angle ACB. Okay, then again we can say that triangle ADC is congruent to triangle ABC. Okay, due to same SSS congruency. Okay, hence we can say that triangle angle, which angle DAC is equals to angle ACB due to CPCT. Here also due to CPCT. Okay, so we can say that therefore we can say that ABCD is a parallelogram. Achha, here something I missed. Here equals to implies that we can say that AB is parallel to BC, so DC. Here also we can say that AD is parallel to BC. Okay, so we can say that it is a parallelogram. Understood? Okay, I'll share with you the note, but in the note I have not proved this. I just wrote the theorems. Okay, because proof is already there in your book, and here also I am explaining all the proofs, so you don't need to write it so much. Okay, in your book it is directly given. So in the note also I have not written, I have not proved the theorems because it is already there in your book, and also here I am explaining. So yes, that's why. Okay, so this was which theorem we completed? Theorem 8.3. Now I will go for theorem 8.4. So in theorem 8.4 it is given that in a parallelogram opposite angles are equal. Okay, so in a parallelogram opposite angles are equal. So here also already we know. Okay, we have already made congruent triangles. So first we will make a parallelogram. This is a parallelogram. What is given in a parallelogram? Opposite angles are equal. Opposite angles matlab this equals to this is equals to this. Okay, so this is suppose A, B, C, D. Okay, so it is all what is given. Now it is a parallelogram. Parallelogram means AB is parallel to DC, it is given, and AD is parallel to BC is given. It is given. These two statements are given. How given? Na, it is a parallelogram. Okay, if AB equals to DC, okay, so या तो we can make a diagonal, okay, या फिर we can take BC and AD respectively as transversal. So this statement how can we prove? So let's again draw a diagonal. Okay, so in this it is already given AB is parallel to DC. Let me draw here like this, it is given. Okay, so so this is AB and this is DC. So let's draw in dotted lines. Okay, so you need to prove the whole angle is equals to this angle. Acha, if I said this angle is equals to this angle, okay, due to alternate angles, I can also say that okay, so this angle is equals to this angle. Again alternate angles. Okay, again alternate angles. How? Na, like this. If we will take like this, this angle is also this equals to this angle. So this equals to this also. That means this plus this whole angle will be equals to this plus this. Yes or no? So hence we can say that angle B equals to angle D. Similarly, if we will prove, if we will draw other side diagonal, okay, similarly we can prove that AD is equals to BC. Sorry, why I am writing AD equals to it. We can prove that this angle DAB angle is equals to BCD angle. Okay, so what I said, firstly we know that this angle is equals to this angle. Okay, again you can say that this angle is equals to this angle. That means addition of these two equals to addition of these two. Yes or no? If this is x, this is x. If this is y, this is y. That means x plus y equals to x plus y. Yes or no? So then we can prove that this angle equals to this angle. Similarly, we can prove that this angle equals to this angle. Hence we can say that in a parallelogram opposite angles are equal. Okay, this is how you will prove. Okay, so this is theorem 8.4. Next theorem is this was 8.5, right? Why I have written 8.4? Opposite angles. Oh. So then comes theorem 8.5. Okay. Theorem 8.5. I'm just writing like that. Theorem 8.5 is the converse of or reverse theorem of 8.4. Okay, there it is given कि in a parallelogram opposite angles are equal. Here it is given if in a quadrilateral opposite angles are equal, then it is a parallelogram. Okay, so I am not writing it. It is given that in a quadrilateral, if each pair of means opposite angles are equal written, opposite angles are equal, it is given. Okay, so prove that it is a parallelogram. So that means if you will draw a parallelogram here like this, okay, so it is given, what it is given, opposite angles are equal, means this equals to this is given, this equals to this is already given. So you have to prove that it is a parallelogram. Obviously we know in the previous theorem we know that in a parallelogram, so here this you need to prove that this is parallel to this. How you will prove that? If you will draw a diagonal, then we can find its alternate angles. Understood? Okay, we can solve it in a very easy method. So let's erase it. So it is given that this equals to this. Okay, this equals to this. So suppose this is x, this is x. Okay, so if this is y, this is y. In angle sum property, okay, we know that x plus y equals to 360 degree, implies that 2x plus 2y equals to 360 degree, implies that x plus y equals to, here 2 will be common, here it is I am doing directly, 2 into x plus y equals to 360 degree, implies that x plus y is equals to 360 by 2, 180 degree. So x plus y is 180 degree, means this angle and this angle, if we will add it, we are getting 180 degree. Hence I told you just before this, I told you, okay, when we can say it is two lines are parallel, if your alternate angles are same, if your corresponding angles are what? Corresponding angles are supplementary. Okay, so here these two internal angles are supplementary. Okay, means their addition is 180 degree. Hence we can say that ABCD is a parallelogram. Okay, so theorem 8.5 is proved. अरे कहाँ गया? हाँ, now comes theorem 8.6. Theorem 8.6. The diagonals of a parallelogram bisect each other. Okay, the diagonals of a parallelogram bisect each other. What does that mean? Let's draw a parallelogram. Did I just draw a parallelogram or bus? Okay, this is a parallelogram. Diagonals of a parallelogram. Diagonals, let's draw a diagonal. This is a diagonal. This is a diagonal. Okay, so it's given that diagonals of a parallelogram bisect each other. Bisect each other matlab अरे यार, this equals to this equals to this, bisect. Okay, so let's name it A, B, C and D. So let's name it O. Okay, so what we can do, just draw AB or parallelogram and measure AO and CO and DO and BO. You will see that AO equals to CO and DO equals to BO, we will see. Okay, and how we will prove that? Similarly, by taking two triangles and by making them congruent, we can prove that AO equals to CO, BO equals to DO. Okay, so one I am doing one, let me do it. In triangle AOB, in triangle AOB and DOC, triangle DOC. Okay, so what is there? Na AB equals to DC. Why? Na parallelogram, opposite sides of parallelogram are same. Okay, and also can I say that angle ABO is equals to angle ODC? Yes, angle ABO, this angle is equals to angle ODC. Why? Na parallelogram na, sorry, parallel lines na, alternate angles are same in parallel lines. Alternate angles are similarly this angle is equals to this angle. Why? Same reason. Angle BAO is equals to angle which one I drew? Sorry, this one, na? Sorry, not this one, this one. Angle BAO equals to angle DCO. Why? Na same. So hence we can say that triangle AOB is congruent to triangle DOC due to SAS na ASA congruency. Hence we can say that this triangle are congruent. Hence we can say that AO equals to CO, BO equals to DO due to CPCT. Okay, these two, AO equals to CO, due to CPCT. Okay, hence proved. Arey yaar, proved. Understood this one? Okay, if you didn't understand, then go back and reverse it, then you can see it again. Okay, so this was 8.6. okay, now theorem 8.7. Theorem 8.7. In 8.7 it is given that if the diagonals of a quadrilaterals bisect each other, then it is a parallelogram. Just the reverse of it. Here it is given that it is a parallelogram. You have to prove that they bisect each other. The diagonals bisect each other. Here it is given that if diagonals bisect each other, then prove that it is a parallelogram. So I am not writing the statement, I am just proving it. Okay, see, so suppose this is A, B, C, D. Okay, let's draw diagonals, because it is already given they bisect each other. That means this equals to this given, this O, this equals to this given. Again we will try to prove both the triangles are congruent. How will prove that? See, given, what is given na, BO equals to DO given, CO equals to AO, it is given. What you have to prove that? Prove that this is a parallelogram. Okay, how will prove that? If we will prove that this angle equals to this angle, means alternate angles. Okay, we just have to prove that this angle equals to this angle, because if alternate angles are same, then these two sides are parallel. Again you have to prove that this angle is equals to this angle, then only we can say that AD equals is parallel to BC. So prove parallelograms means that you have to prove that DC is parallel to AB and AD is parallel to BC. This much you have to prove. Okay, so how to prove? I told you, alternate angles. If you will find alternate angles are same, then you can say that it is a parallelogram. How will get that alternate angles are same? If you will make the triangles congruent. Okay, so here see, in AOB and DOC we can say that this angle is equals to this angle. Why? Na vertically opposite angles. Okay, I am writing here, vertically opposite angles are same. And what else? Already given, BO equals to DO, CO equals to AO, this equals to this equals to such, already given. Then hence we can say that triangle DOC is congruent to triangle AOB due to SAS. Okay, so both are congruent, hence we can say that angle C equals to angle A. Okay, yes or no? Angle C equals to angle A. Also we can say that angle D is equals to angle B. Okay, so hence we can say that this equals to these both are parallel, hence we can say that this is a parallelogram. Okay, I hope you understood. Okay, so last we are having a last theorem. Okay, the last theorem is a quadrilateral is a parallelogram if a pair of opposite sides is equal or parallel. Okay, theorem 8.8. It is given a quadrilateral is parallelogram if pairs of opposite sides is equal and parallel. It is given that, acha, let's draw it. It's given that given what it is given. Now only one pair of opposite sides are equal and parallel, means suppose this is A, B, C, D. It is given that, given what? Now AB is parallel to CD and AB is equals to CD. This much only given. Nothing about AD and BC given, only this much given. You have to prove that. What you have to prove? That this is a parallelogram. How will prove that? If we can prove that alternate angles are same, then we can prove that it is a parallelogram, means you have to prove that this is equals to this. Achha, in these two triangles what it is given? Na AB is parallel to CD. Okay, and we know that if there are two parallel lines, this and this parallel lines, and this is the transversal, that means alternate angles are same, means this equals to this, alternate angles are same. Okay, and it is also given alternate means this angle is equals to this angle, and also it is given that AB equals to CD. Okay, this equals to this, and this is a common side, hence we can say that ABD triangle is congruent to BDC triangle. Okay, both the triangles are now congruent. If they are congruent, hence we can say that AD is equals to BC and AD is parallel to BC. Why? Also I can say that this angle is equals to this angle, CPCT. Yes or no? See, this angle is equals to this angle due to CPCT, and here in this lines like this, na, this equals to this, then hence we can say that AD means this is parallel to this. Okay, hence proved. Okay, so this is the end of your part 2 video. After this we will be doing exercise 8.1, but remember all the questions I won't be doing. I'll just solve some questions which I think it is tough for you, others I will give you as homework. Okay, so yes, complete these 2 videos by Saturday, because on Saturday we will be discussing about all your doubts, and I will be giving some questions to you as well. Also I can give you questions to prove. Okay, theorems you need to see from the book and you need to understand, you need to do by yourself, and you can do. I also explained here. Only the thing what you have to do is you have to write steps according to you. Okay, I didn't write the steps, I just told you how to do. Okay, somewhere I have written, somewhere I have not written, so it's your job to do. Understood? And notes I'll send. You don't need to write from here. Okay, Okay, thank you so much.